we review the first problem that we had solved. We have no issue in that because the point of consideration is already at the corner of the rectangle. The second problem we have solved is the point that we are considering is somewhere below the rectangularly loaded area, and we said that the approach in this kind of problem is to divide the rectangle into four different rectangles in such a way that the point becomes the corner of all the different rectangles. Now, for this third problem, the point is not in the corner, it's not below the rectangularly loaded area, but it is somewhere outside the rectangular loaded area, which is point C. So, the approach in this kind of problem is to introduce an imaginary rectangular load so that point C becomes a corner of the load. So upon introducing the imaginary load, the condition is now satisfied that the point of consideration is in the corner of the rectangular loaded area. And then after which, we will separately analyze the imaginary rectangular load that was introduced. And then eventually, we are going to subtract this imaginary load that was introduced. In short, we analyze the whole rectangle. The blue shaded part is the load that was introduced. And then after which, we analyze separately the imaginary load and then we subtract it. Thus, the equation now becomes the vertical stress increase at point C, Q multiplied by I3 of the extended rectangle minus Q multiplied by I3 of introduced imaginary load. Let us first consider the extended load. B is 3 meters, and this is 6 meters, and this is 1.8 meters. That is 6 plus 1.8 meters. L now is 7.8. We solve for the value of M and N. M is equal to B all over Z. B is 3 meters and Z is 3 meters. So value of M is 1. Next, for the value of N, L divided by Z, 7.8 divided by 3 meters, this is 2.6. Since this value is not in the table, let us use method 1, which is the equation for solving the value of I of, taking into consideration that the terms in arctangent should be in radians. Simplifying, I of 3 is equal to 1 divided by 4 pi multiplied by the quantity 1.105 plus 1.442. I of 3 is 0.2026. Let us now consider the imaginary rectangular area that was introduced. So B is 1.8 meters, the shorter distance, and L is 3 meters. So M is equal to B all over Z, that is 1.8 divided by 3 is equal to 0.6, and N is equal to L divided by Z. 3 divided by 3 is 1, and solving the value of I of 3 through equation, I of 3 now of this imaginary area is 0.136. And if you're going to use also the table, since these values are in the table, from table 3.9, the value of I3 is equal to 0.1361, which is the same as that of the value we got from the equation. Vertical stress increase at point C now becomes the load multiplied by the I of 3 of this extended rectangle minus the I of 3 of this imaginary load that was introduced. So 225 kPa multiplied by 0.2026 minus 0.1361. Vertical stress increase at point C is 14.9625 kPa, and this is now the answer.